This is Pre-Calculus, Section 1.5, Notes, Day 1. So today we're going to be talking about equations, and most of what we talk about today should be review. A linear equation is a first degree equation. So that means that all of our exponents should be ones. That's what makes a linear equation linear. It's x to the first power. So some examples of linear equations. We could have 4x minus 5 equals 3, or x minus 6 equals x over 3. Okay, as long as the x is in the numerator, that's a linear equation. So here's some examples of nonlinear equations. Our first one, x squared plus 5x equals 7. This is nonlinear because it's a second degree equation. We have an x squared. The next one, 6 times the square root of x minus 5x equals 12. Okay, this one contains a square root of x, and remember, radicals are fraction exponents, so this is actually x to the 1/2 power. So that's what makes this equation nonlinear. All of our exponents have to be 1 if we're going to be linear. And then our last one, this one's a little bit tricky, okay, but the problem here is this 5 over x. Now you might say, well, that's an x to the first power, but the problem is it's x in the denominator. So if we bring it up to the numerator, remember we have to change the sign. So that actually makes it 5 times x to the -1 power, and that is not an exponent of +1, so that is nonlinear. So determine whether the given value is a solution of this equation. So we just want to know, if we plug in x equals 2, does it make that equation true or not? Well, the only way is to plug it in and find out. So if I plug in x equals 2, I'm going to have 1 over 2 minus 1 over 2 minus 4, and I want to know, does that equal 1? Okay, well, this is 1/2. 2 minus 4 in the denominator there becomes -2. So I have minus 1 over -2. So chop, chop, right? Minus a negative becomes plus a positive. 1/2 plus 1/2 equals 1. Yes, that's true, right? So yes, x equals 2 is a solution to that equation. What about x equals 4? Do you think that one's going to work too? Let's find out. So we've got 1 over 4 minus 1 over 4 minus 4 equals 1. So this is 1/4 minus 1 over, 4 minus 4 is 0. Equals 1? No. Remember, right here we have a problem. We can't divide by 0. Right? That's a big no-no. So anytime that happens, we can just say, no, this is not a solution. All right, now let's do some solving. My first example, number 1 here, I've basically got two fractions that are equal to each other. This is a family and this is a family, but I've got one fraction equals another fraction. So this one, I might want to just cross multiply. I might want to say that 5 times 2x minus 1 is equal to 4 times x plus 2. When you've got two fractions that are equal to each other, you can just cross multiply. Okay. Then I do distributive property. This is going to give me 10x minus 5 equals 4x plus 8. And now I'm just going to solve for x. So if I subtract 4x from both sides, I'm going to get 6x. If I add 5 to both sides, I'm going to get 13. So I get an answer of x equals 13/6. Can't be reduced, so we're just going to leave it improper. All right, number 2 is a little bit more complicated. Our first denominator is x minus 1. Our second denominator is x plus 1. Our third denominator, that's a DOS, so let's factor it. That can factor into x plus 1 times x minus 1. So the way that we want to solve this equation is by using the LCD, the least common denominator, to clear out all of the fractions. Well, since we've got an x minus 1, an x plus 1, and then we've got a denominator that has x plus 1, x minus 1, our LCD here is going to be x plus 1 times x minus 1. So I am going to go ahead and I'm going to multiply everything in my equation in the numerators by x plus 1, x minus 1. And I'm going to cross out top to bottom. This is going to eliminate all of my denominators. So the equation that I have left will exist only in the numerator. There will be a 1 downstairs. So in the first fraction, x minus 1 cancels x minus 1. In the second fraction, x plus 1 cancels x plus 1. And in the third fraction, x plus 1, x minus 1 cancels x plus 1, x minus 1. So my new equation, after I do that fancy work there, becomes 4 times x plus 1 plus 2 times x minus 1 equals 35. Now that's not so bad. I just have to do a little bit of distributive property. 4x plus 4 plus 2x minus 2. Combine like terms. 4x plus 2x is 6x. 4 plus negative 2 is positive 2. Whoops. Subtract the 2 and divide by 6. So we get x equals 33 over 6, which can be reduced. You can divide by 3 and divide by 3. So x equals 11 halves. Next, we're going to talk about, given an equation with multiple variables in it, rearranging it. So solving it for one variable in terms of the others. And what we're going to do here is we're going to isolate the indicated variable using inverse operations. Right, we're going to undo what needs to be undone to get the variable that we want alone. So in example 1, if we are trying to solve for big M, okay, then we need to look and say, okay, well, what do we need to undo? First of all, I see that big M is being divided by r squared. So the first thing I'm going to do is I'm going to multiply both sides of this equation by r squared. So that's going to cancel the r squared. Now I have f r squared equals big G, little m, big M. Okay. Now my next step is going to be to undo what's being multiplied times m. Big G and little m are both being multiplied times the big M, so I'm just going to divide by both of them at the same time. So that cancels that and that. That gives me my big M alone. I've got f times r squared over big G, little m. So I have successfully isolated my big M. Okay, let's take a look at number 2. Area equals 2 times length times width plus 2 times width times height plus 2 times length times height. And we want to isolate this for W. Okay, so the first thing I'm going to look at is, where does W appear in my equation? And it looks like it appears twice. So I want to get everything that doesn't have W in it away. So the first thing I'm going to do is I am going to subtract this 2LH term over to the other side of the equal sign. Because if it doesn't have W in it, get rid of it. Okay, next step, again, I've got a W here and I've got a W here. What about, since I've got two terms that both have W in them, let's factor W out. So if I take out a W, then I'm going to have 2L plus, whoops, 2H. There we go. And now the last step to getting W alone is just going to be to divide by what's being multiplied times W, which is the 2L plus 2H family. And there is my final answer. A minus 2LH over 2L plus 2H. The last thing that we're going to talk about in this section is absolute value equations. Absolute value, hopefully you remember, means the distance from 0 on a number line. So if we're going to solve this equation, the absolute value of 3x plus 5 equals 7. So first of all, let's talk about what this means. This means that 3x plus 5, plus 5 is 7 units from 0. So this creates two possible equations. It tells us that the equation is either 3x plus 5 equals positive 7, or there's another number that's 7 units away from 0, that's negative 7. So it could also be 3x plus 5 equals negative 7. Okay, and this is because positive 7 and negative 7 are both 7 units from 0 on the number line. So basically we just split this equation into two pieces. We've got our 3x plus 5 equals 7, or 3x plus 5 equals negative 7. And now we just have to do the algebra, and we're going to end up with two possible solutions. So this one is going to give us x equals 2/3. And over here, when we do our algebra, watch your signs. Negative 7 minus 5 is negative 12. This one gives us x equals negative 4. So there are our two answers to our absolute value equation.